Okay, so let's take a look at this question. It says a runner is traveling at a constant rate of 8 meters per second. How long does it take for the runner to travel 100 meters? All right, so now remember what we want to do is we want to first of all identify what is the question. In this case, our question wants to know is how long does it take for the runner to travel 100 meters? That's our question. What information do we know? What information is given? We know that it has a constant rate of 8 meters per second. Now, I see this word constant rate. This word constant rate actually means the same. That's significant. That means he's going to run the same speed the whole time. How do we write it? Remember, we said that whenever we see the word per, we still know that that word per represents a ratio. And we write it special. We write it special by doing the 8 meters per second. Since we also know that the ratios are equal, we're going to set this up again. 8 meters, 1 second should be equal to what other information we know? We know that he traveled 100 meters. But what we don't know is the time. So we got the 100 meters. Notice our meters are on top, seconds on the bottom. Now, like we did in the last problem, we're going to cross multiply 8 meters times 1 second and 1 second times 100 meters. Remember, we're cross multiplying. Remember what Coach McKinney said? Never multiply the units that are the same. So that tells us that we're going to now get that question mark by ourselves because we don't know. We're going to divide by 8. Beside it, divide it. And whatever I do on one side, I have to do on the other side. So I take that 100 and divide it by 8. And it lets me know that it will take us exactly 12.5 seconds to run 100 meters. All right, let's take a look at this. What happens if we want to find out different intervals of this run? The same runner is traveling at a constant rate of 8 meters per second. How far did the runner travel after 1, 2, 5, and 10 seconds? We want to create an equation that gives the distance d that a person has ran if we know the amount of time t they've been running. All right. The best way to do it is we're going to create a table. In this table, we're going to put one side our time. We know that we want to find out what happened. 1 second, 2 seconds, 5 seconds, and 10 seconds. We want to find out what those distances represent. So let's see. Let's bring up our pen. Now, we know that in 1 second of per, remember we said that word per means to multiply, right? So if I take this and I know this will be 8 per 1, his distance will be 8 meters. Well, since we said it means to multiply, if I take that same 8 per 2, it'll be 16 meters. If I take that same 8 per, per mean to multiply, this time 5, it will be 40 meters. If I take that 8 times 10, it will now be 80 meters. Now, when we look at this, what do we notice? We notice that every time this changed, it changed by or increased by a constant. That's what that constant rate is. We know what the constant rate is. The constant rate is 8. So every time this went up, it went a constant rate of 8. So every time we go through this, but I want you to notice that here we got different sets of numbers. That's why it's not 8 then a plus another 8, but it's a constant rate every time we multiply these by 2. Now, with that being said, we are able to create our equation. It asks us for the distance, right? What do we find out about our distance? Well, this distance, it changed based on the time. So we got several times, and it said our time we're going to represent by t. But what did we do to t every time? We multiplied that t by 8. So we were able to create our equation. Our distance is equal to 8 times t, which is that constant. We represented that constant rate per second. The word per means to multiply. Since our time changes, that's where we can use our variable t. This concludes this video.